Welcome to qnawire.
So now we're getting into more complicated molecules. So we look at the skeletal structure thing to give us an idea of how the molecule is laid out. For this first one, it's H bonded to N, bonded to N, bonded to H. But the skeletal structure doesn't tell us necessarily how many bonds. We just know it's at least one. So nitrogen wants to form 3 bonds. It's only formed 2 so far, so I'm going to give it a second one here, mostly because I can't give it a second one to hydrogen. It can only form 1 bond. So now we shouldn't forget our lone pairs here. We can count the number of things around the nitrogen. It's going to be 1, 2, 3. So that makes it sp2 hybridized, both of them. You can kind of see that they're symmetric. You could imagine putting a mirror in between them. And because they're sp2 hybridized, that means that they have a p orbital that's going to be bonding. And that's where our second bond comes from. The reds are p. For this next one, N2H4, we can see the skeletal structure looks like, I'll draw it over here. 2 hydrogens bonded to a nitrogen. That's what the H2N means. And then the N, and then the H2 means 2 more hydrogens. So both nitrogens also have a lone pair. That's because they have 5 valence electrons. They've only formed 3 bonds. They also already have all the 3 bonds that make them happy, which means they're going to be sp3. So they've got 4 things around it. They're 3 bonds and the 1 electron pair. For this next one, we've got a little bit of a kind of lopsided molecule. So we've got H3C. I like to draw that starting with the carbon and then adding on the 3 hydrogens. And then the next one in the line is a nitrogen. And then it's bonded to 2 hydrogens. And if we do a quick check, everything has the number of bonds that it likes. Hydrogen will have 1, carbon has 4, nitrogen has 3, and we just need to add his lone pair there. And since we've got no double bonds anywhere here and no expanded octets, everything is sp3.